My name is Lawrence Liu. I'm a senior SCADA architect with Ovintiv. So Ovintiv is a leading upstream oil and gas company specialized in managing complex assets, focusing on the advancement of technology, focusing on the innovation, and produce 500,000 barrels a day for the North American market, ensuring efficiency and maintaining reliability in high-stakes environments. So our current system, legacy systems, is missing a lot of parts like support of IoT, support of integration with downstream third-party applications. So this is why we're looking for more modern SCADA platform. And the Ignition, of course, jumped up as one of the modern platforms. So with each of these devices and configuration using different communication protocols and data formats, our existing SCADA system, which couldn't be developed further without significant risk, left us with few options. Managing this level of complexity requires a sophisticated metadata model capable of handling operational exceptions and interdependencies flawlessly. Without such a model, we risk incorrect data interpretations, missed alerts, and inefficient control over those assets. With the challenge clearly identified, all we needed was the right partner. We already had 3 contractors fail to deliver a solution robust enough to handle our diverse equipment needs and the complex metadata modeling required for success. We then decided to partner with CSE ICON and task them with leveraging their Upstream Accelerator for Ignition framework to build a replacement for the existing SCADA system.
My name is Ben Vu. I am the SCADA practice manager at CSE ICON, in charge of all of the Ignition SCADA projects over here at the company. CSE ICON is a professional service company focused on the design, development, and implementation of operations technology for manufacturing and processing industries. We are proud to be a long-time inductive automation premier integrator. To help Ovintiv find a new way forward, we began with a 2-week on-site assessment to understand Ovintiv's infrastructure, operational requirements, and metadata modeling needs. Our team needed to get a better idea of the overall landscape by identifying and cataloging all the equipment, data points, and potential interactions. Then the team created a framework to address all of the equipment available at the system.
Over the years, we have used a variety of SCADA platforms, which had to communicate with a range of equipment, including SCADA, PAC, RTU, ABB Total Flow RTUs, Allen Bradley PLCs, and Emerson Rock drivers. These different kinds of devices presented integration challenges. To complicate things further, our production structure includes 3 types of well setups. A single well set, simple configuration with 1 well extracting from a specific location. Commingled well set, multiple wells extracting from 1 specific location. It requires careful data separation. Then a site with multiple wells. This is a complex configuration where several wells commingled and the other wells are separated. This creates intricate operational relationships.
For phase 1, we focused on the functional design specifications. The framework for phase 1 needed to integrate diverse equipment types seamlessly without compromising performance. The framework also had to align with Ovintiv's exacting specifications in regard to look and feel, color, layout, and navigational needs. So the challenge was creating a metadata model that could handle all the situations efficiently and effectively.
Any of the framework we adopt from CSE ICON's Accelerator will be scalable for further development, because this is only the first project with 600 wells. But later we're going to deploy this to a much larger scale of basins. Like a Permian Basin, we have 3,000 wells. Then in the Anadarko Basin, we have another 2,500 wells. Another is we don't want to drag the project year or 2 years. And also alarms, notification, pipelines. So make the data safe and make a command safely sent out.
One of the key things that we gained was customer feedback on the user experience, right? So one of the main things that we wanted to improve upon was the look and feel and the usability of the screen. So navigation, fewer clicks, and making the screens more accessible to the operators was a key point that we picked up from the Ovintiv project. Some of the screens that we built were a CDP view, which is a central delivery point view, which displays all the data for the entire site. Also built a well view for information showing individual wells, and also a tank battery view to monitor storage tank systems. To enhance usability, several supporting tools were implemented for the customer. We built note screens for operational collaborations and record keeping, schematics for piping and instrumentation analysis, alarms for rapid response to critical conditions, maps for spatial awareness for assets, screens to manage all the complex metadata, and system dashboards to do real-time performance tracking for the customer as well.
We have I/O gateway just for pulling the data. Then we have HMI gateway, just get the data displayed to the end users. Then the data modeling design also have a separate table. It's not too many tables. That's hard to maintain, but it has a reasonable segregation of equipment, the sites, the CDPs, the basins. So there's a separation of those. And also there's interdrawing the views from table A to table B. We have make connections of those, and some also a lot of named queries in Ignition being written to address a lot of a customized requirement. All these set up a good foundation, set up good scale for further the new development.
Building on the success of the pilot program, the system is expanded to the full-scale implementation with additional routes and a refined core set of features. Some of the Phase 3 enhancements included an expanded metadata model to accommodate new equipment type and site-to-equipment configurations that weren't in the pilot phase. Some of the key improvements on the final phase included advanced trending capabilities, including quick trends, where the user could right-click any value and instantly trend values over time. We also provided a personalized user experience where the users were able to save shortcuts and frequently used equipments, and for routes for faster navigation. Also enhanced visualization as well as new screens for specialized equipment like slug catchers or pipeline taps, and also visitation metrics as well for administrative work.
Over the course of engagement, we experienced significant efficiency gains in the database structure, performance, and the user experience. These include database optimization, improved query performance and system maintenance by reducing the number of tables from 19 to 10 through efficient data modeling, dramatically improved responsiveness and operator efficiency by decreasing screen load time from 5 or 10 seconds to 0.5 to 1 second. Development time savings: 2 weeks of development time were saved by leveraging assets from CSE ICON's Upstream Accelerator framework, allowing for faster development. Faster database access, intuitive navigation, and enhanced system reliability made the daily operations more seamlessly and efficient. These optimizations not only improve system performance, but also streamlined workflows, ensuring a more responsive and scalable platform for operators.
Prior to being awarded the Ovintiv project, CSE ICON was working internally to develop a Ignition Upstream Accelerator project to help facilitate the quick deployment of an oil and gas SCADA project in Ignition. Some of the things that we looked at were customized metadata model, tag structuring, and also templated screens to help facilitate quick deployment of oil and gas screens and oil and gas projects. We migrated 100 sites, over 600 wells, and built all the custom functionality in 3 months.